So now we're going to divide real numbers. And the truth of the matter is all the numbers that we've dealt with up until this point are real numbers, so that's sort of an unnecessary thing to write, even though what we're talking about is just dividing real numbers. Imaginary numbers have a different method or have a corollary, but special method for division. We're going to just worry about dividing numbers as we know them. In particular, we're interested in using a process of division called multiply. So we want to turn it to a multiplication by the reciprocal or the inverse. Okay, so before I get to that, let's do a quick review of what we know about division already. We have been dividing numbers for years now. We can divide 4 by 2 and get 2. No problem. We can divide 2 by 4 and get either 1/2 or 0.5 depending upon the method we use. Now I, of course, and I'm sure you did too, did this math in your head, this arithmetic in your head, but let's break it down to what we actually did. Let's look at this one first. I took 2, divided it by 4, and then I reduced that fraction by dividing both the numerator by 2 and the denominator by 2, and I got 2 divided by 2 is 1, and 4 divided by 2 is 2. So that's one method. And then the other method, to get a decimal, I would have used long division. I would have taken the number 2 and divided it by 4. 4 goes into 2 0 times, not a problem as long as I convert it to a decimal. 4 goes into 25 times, and I got 0.5. So this is what we're used to doing when we do division, but now we want to turn it into a new process called multiply by the inverse. Obviously, though, before we can do that, we have to talk about what it is to be an inverse. So you remember from the inverse property of addition, that A, some number A, plus the opposite of A equals 0. And what that means is the inverse of A under addition is the opposite. It's what undoes a number under some operation. And the operation here would be addition. So in order to find the inverse under addition, you want to use the opposite. Under multiplication, it's a little bit different, but let's look at what it means, or what it would be. If I were to take some number A, and I want to multiply it by something so that I end up with not 0, but 1. Under multiplication, inverses give us the number 1, or equal the number 1. Well, obviously, what would I have to multiply A by to get a 1? It would be 1 over A. Or the fraction, let me write it this way, 1 over A. So if we do multiplication on this, we get A over 1, right? A times 1 is A, and 1 times A is A, and clearly anything over itself, as long as itself isn't 0, equals 1. So this is the inverse property of multiplication, or the inverse element or the reciprocal element. So a bunch of words just came up all of a sudden. So the element that we use to undo a number under multiplication is called the reciprocal. And you'll remember that from elementary school math. But we want to change and start using the word inverse. So instead of reciprocal, we're going to say the inverse. Inverses play a huge role in algebra in many, many different ways, and so it's a good habit to get into using that language rather than reciprocal, because the inverse is what it is actually known as. All right, so let's do a couple examples real quick. Let's identify the inverse of the number -1/7. So this is a rational number, and I want to know what would I have to multiply this by to equal 1. Well, clearly, if I want a +1, I'm going to have to multiply it by something negative. So the sign doesn't change. It's not like an additive inverse where I have to use the opposite sign. In multiplication, I don't use the opposite sign, and I don't have to memorize that because I can easily do what I'm doing now, which is say, well, if I want a positive number here and I'm starting with a negative, I'm going to need a negative. And then what would I be able to multiply this number by to give me a 1 so that all the values cancel out? And that would be 7. So the reciprocal of negative 7 is negative 1/7, but the inverse of negative 1/7 would be negative 7. Well, what about negative 5/3? Again, I'm asking what would I have to multiply this by to get 1 out? So just like before, we want to look at the signs first. If I multiply a negative times a negative, I'm going to get a positive. And then I'm going to multiply a fraction or a rational number by its reciprocal. And then let me just test it to be sure I've done the right thing. Negative 5 times negative 3 equals, well, let's put it down here because I don't really know what equals yet. Negative 5 times negative 3 equals negative 15 equals positive 15 over 3 times 5 equals 15. 15 over 15 equals 1, and I've gotten exactly what I hoped for. All right, I think now we're ready for a rule or a property. In this case, it's the division rule. And the division rule says that for a number a divided by b, that is the same thing as the number a times the reciprocal of b. Okay, so the division rule just says to divide one number by another, you're going to convert it to multiplication and multiply by the reciprocal of the second number. So in new language, that was language we remember, right? Talking about the reciprocal, we say a divided by b equals a times the multiplicative inverse of b. I could even write that. All right, so let's put it all into action. Example 3, 18 divided by negative 3. So in algebra, we convert this to 18 times the inverse or the reciprocal of negative 3, which would be 1 over negative 3. Now multiply across. 18 times 1 is 18. Divided by 1 times negative 3, 18 over negative 3. And now I can reduce. So 18 divides by 3, leaving 6. Negative 3 divides by 3, leaving negative 1, which means negative 6 is my outcome. Notice that the negative rule for multiplication carries through in division because division really is just multiplication, and that's what the division rule shows us. We turn division into multiplication because division really is a multiplicative process. So I had one negative sign in the original problem. That means I have a negative solution at the end. Example 4. Negative 16 divided by negative 8/3. So first step, and you have to write this step out, at least while you're in Algebra 1. First step is to write negative 16 times the multiplicative inverse of negative 3/8, and that's just negative 8/3. I was thinking ahead of myself, and that's just negative 3/8. So you can see that the multiplicative inverse is just the reciprocal of the fraction that you have. And that equals negative 16 times negative 3. I'm going to write this step out just to make it abundantly clear what I'm doing, over 1 times 8. Now multiply across. Negative and a negative is a positive. 16 times 3 is 48, divided by 8. So now reduce this fraction. I'm going to do it twice just to show the steps when you have more than one. I know they both divide by 2. I also know they both divide by 8. But let's say I don't recognize that, but they're both even numbers, so I see they divide by 2. Dividing 48 by 2 is super easy, 24. Dividing 8 by 2 is easy, I get 4. So my answer is 6. Suppose I'm working with a number I don't see that, I could just do it again. 24 divided by 2 is 12, 4 divided by 2 is 2, and eventually I get to my 6. So you can do reductions by canceling out. I'm assuming that you're really good at reducing already, and so you don't have to show those steps. You just have to make your reduction. Okay, so I'll admit that so far this seems like a bunch of hoopla around making harder a process that you already know. But I'm hoping that using easier numbers showed you the process, because we're going to now use it in a different way. And here is that way. Da, 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 da. Example 5. We want to divide 40x plus 32 by 8. Okay, go ahead, get started. Okay, I'm going to show you actually. All right, so the first step, we want to do exactly the same steps we did here before. I can say this. We want to do exactly the same thing we did up here, only we're going to do it with this bigger polynomial. So first thing is I want to turn it into a multiplication by the inverse. So I have 40x plus 32 times 1 over 8. Okay, well, that's just 1/8 times 40 over x, and I'm going to write the whole step out. So this is distribution, right? 1/8 times 40 over x, which is 40x divided by 8, plus 1/8 times 32. Okay, now I can do my cancellations, right? 40 divides by 8, well, let's do it in a couple steps. 40 divides by 4, leaving 10. 8 divides by 4, leaving a 2. That equals 5x. And then 32 divides by 8, I just know that one off the top of my head. 5x plus 4. Super easy to handle. Hardly took any more work to do this big ugly number than it took to do these simple numbers. So in conclusion, we have discussed we have identified the multiplicative inverse of any number. We've converted, using the division rule, we've converted division problems into multiplication problems, and we have used that process to divide polynomials by monomials. And later we'll be able to do the same thing to divide polynomials by polynomials and radicals by radicals, or any combination of the numbers that we know.